the form the square root of a squared minus x squared. And today we look at integrals of the form the square root of a squared plus x squared dx. So just like we did yesterday, you will have to make a substitution, and then once you have substituted, you will notice that what you have to integrate is much simpler than what you started with. Now the substitution we make in this case is we let x equal to a tan of theta, and from that we can work out dx. This is a squared sec squared theta d theta. Then we substitute it in there. So if we want to work out the integral, the square root of a squared plus x squared dx, this is the integral of a squared, and then x squared, we square this, we get a squared plus tan squared theta. And then dx is a squared sec squared, sorry, dx is just a, dx is a sec squared theta d theta. This is a sec squared theta d theta. Then you can see here that a is a common factor, so we can factor that out. We have the integral, the square root of a squared 1 plus tan squared theta multiplied by a sec squared theta d theta. And we know that 1 plus tan squared theta is a sec squared theta, and then the square root of a squared sec squared theta is just a sec theta. So what we have to integrate is a squared and then sec to the power of 3 of theta d theta. Okay, so we know how to integrate this. We've done integrals where we have powers of all of our ratios. So we would split this up as sec squared times sec theta, then change the sec squared and rewrite it as 1 plus tan squared theta, and then integrate from there. So this is the integral of a squared sec squared theta times sec theta d theta, integral of a squared 1 plus tan squared theta sec theta d theta, a squared sec theta plus a squared sec theta tan squared theta d theta. So here to integrate this one, we have to use integration by parts. Integrating this one, we know how to do it. That's just ln of sec theta plus tan theta, and then here we use by parts. So this is a squared ln sec theta plus tan theta, and then plus a squared, we have sec theta, tan theta, tan squared theta, d theta. Okay, so we need to pick our u and our dv, so we can let u equal to tan theta, and dv will be sec theta tan theta, and this means that du is sec squared theta d theta, and v is a d theta here, and v is sec theta. Okay, so now substituting that into this integral here, we have a squared ln of sec theta plus tan theta plus a squared. The integral is u times v, so we have sec theta tan theta minus the integral of v times du. So we have a sec to the power of 3 of theta d theta. And we close the brackets. Okay, we'll then multiply out the brackets. So this is a squared ln of sec theta plus tan theta plus a squared sec theta tan theta minus the integral of sec to the power of 3 of theta d theta. Okay, then we have to remember what is it that we were integrating. We were integrating a squared sec squared theta. This is what we're integrating. And then we have a squared here as well. And then we have a squared. Okay, so we multiply out the brackets like that. So it's a squared, the integral of sec squared theta. So you have one on the right hand side and another one on the left hand side. So you take this one to that side. So you have 2 multiplied by a squared sec cubed theta d theta. This is equal to a squared ln of sec theta tan theta sec theta plus tan theta. Then there was a squared sec theta tan theta. Okay, so we only want this integral, so we would have to divide by 2 throughout. So we have the integral of a squared d theta. This is a squared over 2 ln of sec theta plus tan theta plus a squared over 2 sec theta tan theta, and then we add a constant of integration there. Okay, then keep in mind that there was no theta when we started, so we would have to then rewrite everything in terms of x. So this one here, a squared sec cubed theta d theta. We look at, where's that? This is the same as the square root that we were trying to integrate. So we have the integral of the square root of a squared plus x squared dx. Then we need to substitute all these thetas that we have. So the substitution that we made was x is equal to a tan theta. So it means that tan theta is equal to x over a, and theta is tan inverse of x over a. So here. So we said that x is equal to a tan theta. This means that theta is tan inverse of x over a, and we need sec theta. So to get sec theta, we draw our triangle. So this is our right angle triangle. Theta goes over here. And from this, you can see that tan theta is x over a. So it is opposite over the adjacent. And this is a squared plus x squared. And then sec theta, sec is the reciprocal of cos, and cos is adjacent over hypotenuse. So sec is the hypotenuse over the adjacent. So sec theta is going to be a over the square root. Sorry, sec is hypotenuse over adjacent, not adjacent over hypotenuse. So it's a squared plus x squared over a. Okay, so we have everything we need in order to substitute. Now we'll just go ahead and substitute. A squared over 2, this is just a squared over 2. And then we have ln of sec theta, which is the square root of a squared plus x squared over a. And then tan theta is x over a. And then we add a squared over 2 sec theta, square root of a squared plus x squared over a. And then we multiply that by tan theta, which is x over a plus c. Okay, so what you'll notice in the book, or what was done, is here what we're taking ln of this, the denominators are the same, so you can combine the fractions. So you'll have the square root of a squared plus x squared plus x, then the whole thing is over a, and then you can split up your logarithm, and you have a squared over 2 ln of the square root of a squared plus x plus x squared plus x minus a squared over 2 ln of a, and that is a constant. So that you can write as a squared over 2 ln of the square root of a squared plus x squared plus x minus a squared over 2 ln of a plus x over 2 square root of a squared plus x squared, and then c. But you can see that this is a constant, that is a constant, and you can combine them together, and then we can conclude that the integral of the square root of a squared plus x squared dx, this is just a squared over 2 ln of the square root of a squared plus x squared plus x minus plus x over 2 square root of a squared plus x squared, and then plus your constant c over there. So the over a there is not really needed. So again, This is a formula that you can use if you can remember it. But then again, that will depend on how many marks the question is. If the question is like 3 marks, then by all means just use the formula, substitute your a wherever it goes, then you have the integral. But when the question is 8, 9 marks, we want to see all your working. So don't just use the formula. And I haven't seen any integral questions that are like 3 marks. So you will have to show all your working with this. And we look at some examples. Number 1, we have the integral of the square root of 1 plus x squared dx. So in this case, our a is 1. So x is going to be equal to 1 tan theta, which is just tan theta. And that means that dx is equal to sec squared theta d theta. And then we substitute, we get the integral of the square root of 1 plus tan squared theta. And then multiply by dx, which is sec squared theta d theta. We know that 1 plus tan squared theta is sec squared theta. The square root of sec squared theta is sec theta. So sec theta times sec squared theta is sec to the power of 3 of theta. So the integral of sec to the power of 3 of theta d theta, that is
Quickly
what
go back, please.
That is what we are trying to work out.
Yeah.
Okay, and then sec to the power of 3 of theta, we said we will have to rewrite it as sec squared times sec. So this is the integral of sec squared theta times sec theta d theta. And then sec squared is 1 plus tan squared. So we're integrating sec theta plus sec theta tan squared theta d theta. Then here, this one, we know what the integral is. And then this one over here, we have to use by parts. So we let u equal to tan theta. Du is sec squared theta d theta. And dv will be sec theta tan theta d theta, and that means that v is sec theta. Now we can integrate everything. The integral of sec theta, we said, is ln of sec theta plus tan theta. And then the integral of sec theta tan squared theta using by parts is u times v. So this is sec theta tan theta minus, yeah?
I'm a bit confused. Aren't we trying to find 10 theta d theta according to the chain rule?
Aren't we trying to find what?
10 theta, the integral of tan theta.
Where's the integral of tan theta? Or why?
Quickly go back. Yeah. The 10 and the sec, isn't it like sec squared is a derivative of, like in the examples we were doing yesterday, man, whereby you said when you have like 10 theta sec squared theta, you say that you have 10 squared theta divided by 2, like the chain rule, man.
No, here they are not multiplying. It's this. You can see that this is under a square root. This is not under the same square root. So it's not even just multiplying 10 squared theta. You would have to put it under the square root and multiply it out. So it'll be sec to the power of 4 sec squared theta tan squared theta sec to the power of 4 of theta, and everything is under the square root before you use the chain rule. So it's different if the square root was not there. If the square root was not there and I just had 10 squared theta sec squared theta, then I can just say that's 10 to the power of 3 divided by 3. That would be fine, but because of the square root here, you cannot do that. Okay, so this is the integral of sec theta. Then to integrate this one here, we use the by parts method. So it's u times v, so it's sec theta tan theta, and then minus the integral of v times du. That will be sec cubed theta d theta. So you can see this is what I have on the left hand side, and this one here is on the right hand side, so I can collect both of them on the left hand side. See, it's negative. Excuse me. See, it's negative. When it goes to the other side, it becomes positive. So I have 2 sec the integral sec cubed theta d theta. This is equal to ln of sec theta plus tan theta, and then plus sec theta tan theta, and then we divide by 2 on both sides. So the integral sec cubed theta d theta, this is equal to ln, there's a half here, ln of sec theta plus tan theta plus a half sec theta tan theta, and then you add your constant of integration. Then again, what we need to do is now rewrite everything in terms of x. So if you remember what we had here, this sec cubed theta is just the square root of 1 plus x squared dx. So we have, I should write down what we substituted first. So we said x is equal to tan theta. And this means that theta is tan inverse of x. And then we need sec theta, which we are going to substitute over here. So we draw our triangle. So this is our right angle triangle. Put theta over here. Just draw that better. Put theta over here. And we said that tan theta is x, which is x over 1. So opposite over the adjacent, and this is 1 plus x squared. Okay, so sec theta here is the hypotenuse divided by the adjacent over 1, which is just 1 plus x squared, everything under the square root. So now we have everything in terms of x. We can just substitute into this formula over here. So this one, sec to the power of 3 of theta, we say that is the square root of 1 plus x squared. We have the integral of the square root of 1 plus x squared dx. This is equal to a half ln of sec theta, which is 1 plus x squared, sec theta plus tan theta, which is x, and then plus a half sec theta times tan theta. So sec theta is the square root of 1 plus x squared, and then tan theta is x. So I can put plus and the x over there. So my integral, and then you add your constant of integration. Okay, so it's half ln square root 1 plus that. Okay, and that is fine. So that is how we do it. So this one seems a little bit longer than yesterday's. Well, not that much longer, but it's just algebra, which I think we should not have any problems with. Number 2, we have the integral of the square root of 25 plus x squared. So here our a is 5. So here we can let x equal to 5 tan of theta. This means that dx is 5 tan squared theta, sec squared. Theta d theta. Then we substitute in there. We have the integral of the square root. We have 25 plus, when we square this, we'll have 25 tan squared theta. So we can already factor out the 25. We have 1 plus tan squared theta. And then dx, this is 5 sec squared theta d theta. So the square root of this, we know that 1 plus tan squared theta is sec squared theta. So we have 25 sec squared theta under a square root. That is 5 sec theta. So we have 5 sec theta times 5 sec squared theta. That gives us the integral of 25 sec to the power of 3 of theta d theta. So that is what we want to integrate. And when we integrate this, it is the same as integrating that over there. So 25 sec squared theta, this is 25. Then we say sec squared theta times sec theta d theta. And then sec squared we write in terms of tan. So the integral of 25 1 plus tan squared theta sec theta d theta. Multiply out, we have 25 sec theta and then 25 sec theta tan squared theta d theta. So this one, we know the integral is just ln of sec theta plus tan theta, And to integrate this one, we have to use by parts. So we have u is equal to tan theta. That means that du is sec squared theta d theta. Then dv dv is sec theta tan theta d theta, and then that means v is sec theta d theta. Okay, so we can now integrate. The integral of 25 sec theta is 25 ln of sec theta plus tan theta, and then we have 25 multiplied by the integral of this, which we use by parts, so u times v, so it's sec theta tan theta minus the integral of v times du. So v times du is sec to the power of 3 of theta d theta, close the brackets. Okay, then this 25 we can multiply it out, so we have 25 ln of sec theta tan theta plus 25 sec theta tan theta minus the integral of 25 sec to the power of 3 of theta d theta. So you can see that what I have here on the left hand side is the same as what I have here on the right hand side. So this one I have to take it to the other side, and then I will have 2 times the integral of 25 sec cubed theta d theta. So that is 2 integral of 25 sec cubed theta d theta. This is equal to 25 ln of sec theta plus tan theta plus 25 sec theta tan theta. I have 25 ln sec theta plus tan theta sec theta tan theta, and then the integral of 25 sec cubed theta d theta. This is 25 over 2 ln sec theta plus tan theta plus 25 over 2 sec theta tan theta plus our constant. And now we need to rewrite everything in terms of x. So we say that x is equal to 5 tan theta. So this means that theta is tan inverse of x over 5. Okay, I don't know why I've been writing theta when I never use it. So I don't even need to find theta itself. Okay, so this would mean that tan theta is equal to x over 5. And then we can work out sec theta by drawing our right angle triangle. So this is theta there. Tan theta is opposite over the adjacent. So this is 25 plus x squared. So from here we can see that sec theta is equal to the square root of 25 plus x squared over 5. Okay, then we substitute all the terms in there. So we have the integral of the square root of 25 plus x squared. That is this one over here, dx. This is 25 over 2. And then we have ln of sec theta. This one, square root of 25 plus x squared over 5. And tan theta is x over 5. And then we have 25 over 2. Sec theta is the square root of 25 plus x squared over 5. And then tan theta is x over 5. So you can see the 25 and the 5 and 5 there will cancel. And then here in this bracket, you can rewrite it so that it's everything over 5. And then you can split it up as 2 logarithms, where one has the numerator, the other one has the denominator. And then the one with the denominator is a constant, which you will add to this constant here. So what we are left with is the integral of the square root of 25 plus x squared dx. This is 25 over 2 ln of the square root of 25 plus x squared plus x, then plus x over 2, and then I still have a constant here. I will put this one in red. It's still a constant, but it's a different constant from this one, because you can see that here there was a 5 in the denominator, but over here there is no 5 in the denominator over there, because I split the logarithm so that that constant is added to the constant that was already outside. Okay, number 3. I have the integral of 4x squared plus 9 dx. So remember, before we use the technique, we must have a squared plus x squared. So we don't want any coefficients of x squared here. So we factor this 4 out. So this is the integral of the square root of 4. Then we have x squared plus 9 over 4, like that. And then the 4 can go outside. When it goes outside of the square root, it becomes 2. So we're having 2, or we have 2 square root of x squared plus 9 over 4 dx. Okay, so this one here is in the form that we want, so we can make the substitution now. So we let x equal to a is 3 over 2, so it's 3 over 2 and then tan theta, and this means that dx is 3 over 2 sec squared theta d theta. Okay, then proceeding as always, we make the substitution. So we have 2, the integral of the square root. So x squared will be 9 over 4 tan squared theta. So I can see 9 over 4 is a common factor. Then I have tan squared theta plus 1. And then dx here, it's 3 over 2 sec squared theta d theta. So times 3 over 2 sec squared theta d theta. So again, 10 squared theta plus 1 is sec squared theta. So I have 9 over 4 sec squared theta, which is 3 over 2 sec theta, which I multiply by that. So I have 2 times the integral of 9 over 4 and then sec to the power of 3 of theta d theta. And then, as usual, sec to the power of 3 of theta d theta we write as sec squared times sec. So this is 2 9 over 4 sec to the power of 2 theta sec theta d theta. And this is 2 integral 9 over 4 1 plus 10 squared theta sec theta d theta 9 over 4 sec theta plus 9 over 4 sec theta tan squared theta d theta. Okay, so again, we know how to integrate this one. It's just ln sec theta tan theta. And then this one we have to use by parts. So u is equal to tan theta. That means that du is sec squared theta d theta. And then dv is sec theta tan theta d theta, and v is equal to sec theta. Okay, so our integral, this is 2, and we have 9 over 4 ln of sec theta plus tan theta, and then u times v sec theta tan theta minus, getting the 9 over 4, minus 9 over 4, the integral of v du, which is sec to the power of 3 d theta. Okay. Let's just see if it's correct. Okay, then I need to close, yeah, this bracket. Oh, all the brackets are closed. So that one is that one there. Okay, so the 2 multiplies everything here. Okay, so we can multiply the 2 out for these terms, and then we leave it outside here, and then this 9 over 4 goes there, so that it's exactly the same as what we have over here, so that we can take it to the other side and add them together. So we have 9 over 2 ln of sec theta plus tan theta plus 9 over 2 sec theta tan theta, then minus 2 times the integral of 9 over 4 sec theta sec cube theta d theta. So this one here is what you have on the right hand side. This is what you have on the left hand side. So you can combine them, and then you see one is negative, the other one is positive. When it goes to the other side, they are both positive. So what I have will be 4 integral 9 over 4 sec to the power of 3 of theta d theta. This is equal to everything else that we have here, 9/2 ln of sec theta plus tan theta, and then 9/2 sec theta tan theta. Okay, so remember we want 9/4 sec to the power of 3 of theta d theta. So we divide everything by 2. So we have 9/4 ln sec theta plus tan theta plus 9/4 sec theta tan theta. Then we have our constant. Then substitution, we said x is equal to 3/2 tan theta. This means that tan theta is equal to 2x/3. And yeah, we can just draw our triangle. Theta over there. And here we have 2x, we have 3, or we can have 3/2 here. And then this is x squared plus 9/4, just so that it looks like the way it was in the question. But either way, it doesn't matter. Okay, so this is 2. Okay, then now we are ready to substitute. Just sec theta is the hypotenuse over the adjacent, like that. And now we substitute over here. So 9/4 sec cubed theta d theta, that is this term here. In fact, the whole thing with the 2 here as well. So you can see with the 2 and that's how we get this. So the 2 is part of the integral that we need. So 2 times this whole thing, that is the integral of the square root of 4x² plus 9. And then we have 9/4 ln of sec theta. Sec theta is the square root of 4x² over 3. Then tan theta is 2x over 3. And then we have 9/4 sec theta is the square root of 4x² plus 9 over 3, and then tan theta 2x over 3. So those will cancel, and the 4 in there. So I have x over 2, the square root of 4x² plus 9. And then here I have 9 over 4 ln of that. Okay, so similarly here, this 3 in the denominator, so we have a constant there. So this 3 in the denominator, we can split it up and rewrite it as a different integral, not integral, as a different logarithm, and that logarithm is a constant which we add to this constant over here. So what we are left with, the integral of x squared plus 9. This is equal to 9 over 4 ln 9 over 4 ln of 4x squared plus 9. Then plus 2x and here we're left with x over 2 and the square root 4x squared plus 9. And here we still have a constant, but this constant here is different from this one because we've added the constant that we get from this denominator over here. Okay, yeah, it's fine. Yeah. Okay, then with number 4, I think we'll only be able to do part of it, not all of it, since we have only 5 minutes. But with number 4, basically what we have to do is complete the square. And after you have completed the square, then you will proceed as normal. You just make a u substitution. So we have the square root. Yeah, you're very soft.
Yeah, before you continue, ma'am, can you hear me now?
Yeah.
Okay, what you did at learn, I don't understand. Did you take out the 3 from the brackets or what happened?
Yeah, like if I have ln of 2 over 3, let me say 2, let me make this x plus a constant. This is ln of x plus ln of 3 plus the constant. This is a constant, that is a constant. Together they make a constant. So I can just write this as ln of x plus c.
Oh, okay. Thank you.
Okay, so we have 5 minus 2x plus x squared dx. So here we said what we need to do is first complete the square, and then rewrite it in that form where it's something squared plus a constant that is being squared. So go ahead and complete the square here. We'll have the integral of x plus 1, x minus 1. Yeah, x minus 1. As we divide that by 2, get minus 1 squared. And then minus 1 plus 5 is plus 4. And then, yeah, plus 4. The square is complete. This is dx. So here we would make a u substitution. So u is equal to x minus 1. This means that du is equal to dx. So what we are integrating is actually the integral of u squared plus 4 du. Okay, and then this is in the form that we want. So we can now just go ahead and make the trigonometric substitution. So we will say that a is 2, so u is equal to 2 tan theta, and that means that du is 2 sec squared theta d theta. Then you would go ahead and substitute the way we always do. This is the integral, the square root. We have u squared, which is 4 tan squared theta plus 4. So 4 is common, we can factor that out. And then du, we just put 2 sec squared theta d theta. So this is the 4, 1 plus tan squared theta. And then instead of dx, we put 2 sec squared theta d theta. So this is sec squared theta d theta. This is the integral of, there's a 2 here, this 2 here, that one. So this is 4 sec to the power of 3 d theta. And now we want to integrate it. So the steps to integrate this are always the same. This is the integral for sec squared theta, sec theta d theta, the integral of 4, 1 plus tan squared theta, sec theta d theta, 4 sec theta plus 4 sec theta tan squared theta d theta, and then we know how to integrate that one. This one we must use by parts. U is equal to tan theta d theta, du is sec squared theta d theta, dv is sec theta tan theta d theta, v is sec theta. Okay, so now we integrate. We have 4 ln of sec theta tan theta plus 4 times uv, which is sec theta tan theta, minus the integral of 4 v du, which is sec to the power of 3 of theta d theta. So you can see this is what I started integrating, and the same thing has appeared over here. So I take this to the other side, then I would have 2 multiplied by 4 sec cubed theta d theta. This is equal to 4 times that. So we have 4 ln.
Class participants on the other side.
What? tan theta, and then 4 sec theta tan theta. Then we divide by 2, the integral of 4 sec cubed theta d theta. This is 2 ln of sec theta plus tan theta plus 4 sec theta tan theta plus our constant of integration. Then now substituting, we say that x is 2 tan theta. So this means that tan theta is x over 2. And then we draw our right angle triangle. This is x over 2. And this is not x, sorry, it's u. So this is u squared plus 4. And this means that sec theta is equal to the square root of u squared plus 4. Okay, and then you need to just remember that u is x minus 1. So this is x minus 1 over 2, sec theta over 2. So this is the square root of x minus 1 squared plus 4. And then the whole thing is over 2. Okay, then I think you can do the substitution by yourself. Then remember, when you have a common denominator here with your ln, you can always take that out and combine it with this c. So it looks like it has just disappeared, but what has actually happened is that you have combined it with the constant that is outside there already. So there are questions in your exercise, but like I said, this substitution is a little bit longer than the one we did yesterday. So we don't even have time to look at some of those exercises, which you should try by yourself. Then tomorrow we look at another integration technique that involves trigonometric substitution. Right.